Today's topic is Chat and DALL-E. 1. Introduction. Artificial intelligence AI has taken a monumental leap forward in the past decade. From voice assistants to autonomous vehicles, AI is becoming increasingly embedded in daily life. Among the most impressive advances are Chat, a conversational AI capable of engaging in human-like dialogue, and DALL-E, an AI system that can generate images from textual descriptions. These tools reflect the growing power of generative AI, a field focused on producing new content rather than merely analyzing existing data. 2. The origins of Chat and DALL-E. OpenAI, founded in 2015, has been at the forefront of generative AI research. Initially a non-profit research lab, OpenAI's mission is to ensure that artificial general intelligence (AGI) benefits all of humanity. OpenAI first released GPT generative PRE-trained transformer in 2018. It evolved through GPT-2, GPT-3, and GPT-4, with performance improving significantly at each stage. Meanwhile, DALL-E was introduced in 2021 as a creative offshoot of GPT-3, designed to generate images from text prompts. A more capable version, DALL-E 2, was released in 2022. 3. What is Chat? Chat is a conversational model based on the GPT architecture, which uses a form of deep learning called the transformer. It is designed to understand and generate human-like language. 3.1 Natural Language Processing (NLP). NLP is the field of AI concerned with the interaction between computers and human language. Tasks include text generation, translation, question answering, sentiment analysis, summarization. Chat is trained on a wide range of these tasks and can perform many simultaneously due to its general-purpose architecture. 3.2 GPT architecture. GPT stands for Generative PRE-trained Transformer. Let's break this down. Generative. It can generate coherent sequences, for example, paragraphs of text. PRE-trained. Initially trained on a large corpus of internet text. Transformer, a deep learning architecture introduced in 2017 by Viswani AI. It uses self-attention mechanisms to model sequences. The key components of the transformer are input embeddings, convert words or tokens into vectors, positional encoding, add sequence information, multi-head attention, enables the model to focus on different parts of a sentence simultaneously, feed forward layers, process attention outputs, residual connections, and layer normalization, improve training efficiency. 3.3 Training process. The training process has two main phases. 1. Pre-training. The model learns to predict the next word in a sentence given the context. This phase uses massive datasets from books, websites, and articles. 2. Fine-tuning. Tailors the model for specific tasks or safety purposes using curated datasets. Chat also uses reinforcement learning from human feedback (RLHF), where human annotators rank responses to fine-tune behavior. 3. For how Chat works. When a user enters a prompt, Chat follows these steps. 1. Tokenization. The input text is broken into smaller parts tokens. 2. Encoding. Tokens are embedded into vector space. 3. Attention. The model identifies which words to focus on. 4. Decoding. The model generates the next tokens based on probability distributions. 5. Sampling. Several techniques like greedy decoding, beam search, or top K-top-P sampling are used to finalize the output. 3.5 Applications of Chat: customer support, education and tutoring, programming assistance, for example, GitHub Copilot, creative writing and brainstorming, data analysis and summarization. 4. What is DALL-E? DALL-E is a generative model that creates images from textual descriptions. For example, an astronaut riding a horse in a futuristic city. 4.1 What makes DALL-E unique? Unlike other image generation models that need labeled training images, DALL-E is trained to generate images conditioned on text. It bridges vision and language, using techniques from both NLP and computer vision. 4.2 DALL-E architecture. DALL-E uses a transformer-based architecture, like GPT, but trained on pairs of text and images. It consists of text encoder, converts the prompt into a vector. Image decoder, generates images based on the encoded prompt. Clip contrastive language image PIE training, a vision language model used to guide image text alignment. In DALL-E2, the model first generates a semantic image representation, which is then converted to a high-resolution image using a diffusion model. 4.3 How DALL-E works. 1. Prompt encoding. Text is tokenized and embedded. 2. Image generation. DALL-E 1 directly generates pixels. DALL-E 2 generates image features, then uses a decoder like a diffusion model to render images. 4.4 Applications of DALL-E. Art and illustration, product design and prototyping, marketing and content creation, accessibility tools, scientific visualization. 5. Training large models. 5.1 Data collection. Data includes books, encyclopedias, Wikipedia, web data, common crawl, dialogue transcripts, image caption pairs. For DALL-E. 5.2 Tokenization. Text and images are broken into smaller units by pair encoding, BPE for text, vector quantization or patch embeddings for images. 5.3 Pre-training vs. fine-tuning. Pre-training teaches general language or image knowledge. Fine-tuning specializes the model for safety, ethics, or task-specific use cases. 5.4 RLHF Reinforcement learning from human feedback. RLHF uses reward models trained on human preferences. The model explores responses and is rewarded or penalized based on how good the answer is. It helps chat be more helpful, avoid toxic or harmful content, improve alignment with human values. 6. Technical challenges and solutions. Some key challenges: bias and fairness, computational cost, hallucination, confidently incorrect answers, prompt sensitivity, robustness to adversarial prompts. Solutions include continual fine-tuning, filtered training data, human feedback loops, external tools and plugins to verify output. 7. Limitations and risks. Despite its strengths, generative AI has notable limitations: factual inaccuracy, bias and stereotypes, over-reliance on patterns from training data, security threats, for example, phishing, misinformation, intellectual property concerns. DALL-E in particular can raise issues around deep fakes, art plagiarism, sensitive content generation. The future of generative AI. Emerging areas: multimodal AI, combining text, image, audio, video, real-time applications, agents, bots, creators, personalized AI, autonomous tools, autoct agents, smarter, safer models via continual learning. Expected improvements: better memory and context, integrated reasoning, lower energy consumption, open source alternatives. 11. Conclusion: Chat and DALL-E are groundbreaking AI systems that exemplify the power of generative models. Chat shows how machines can engage in human-like conversation, while DALL-E showcases how text can drive visual creativity. Their design, based on large-scale transformers, allows them to generalize across tasks with impressive versatility, yet they come with real challenges. Balancing innovation with responsibility, creativity with control, and access with ethics remains a central issue for AI's future. Thanks for watching.